Hello Gophers! Welcome to this new series of videos on programming languages. This time I will explain how to mock HTTP requests in Go. The goal is to be able to test code that triggered HTTP calls very easily. So let's get started. I have built a web crawler and page analysis tool for data portability, and I needed a tool to make it easy to write HTTP tests. So, to summarize my requirement, I needed a tool to write stable and reproducible tests. The goal is to be able to work consistently no matter what changes happened on the target page or on the target API. I also wanted a tool that helped me write tests that run fast and can work offline. So I need to be independent on the network connection. And I also needed a tool that is easy to set up. I want to add new HTTP tests very easily. I didn't find any suitable tool, so I decided to write my own HTTPMock library to address my own needs. To address those requirements, I have designed HTTPMock library on top of two tools. The first tool is a recorder command line application that performs real HTTP requests and stores the behavior in a scenario file. The second tool is an instrumented HTTP client in Go that can load a scenario file and trigger predefined responses in your own code. Installing the recorder is very simple. You can install the recorder using go-get command line tool. So here we're installing the HTTP recorder tool. So this is very easy. You just do a go-get and we download HTTP tool and all the dependency. And now we have the HTTP tool, which is available. Recording a scenario is also very simple. You can add a request in a scenario file by using HTTP add for each request you want to add in your file. So you can store as many requests as you need in a given scenario file. So now that we have installed the HTTP recorder tool, we can use it to record a scenario. So we will create a directory to store our scenario files. And then we can add a request. For example, here we are storing a request to Process1 website. We can also add flux.io website, and that's it. We have created a scenario file containing two groups of requests. The resulting scenario consists in three types of files. The scenario files, which store the request in JSON format. The URL file, which is just a summary of all the requests you have in your scenario file. And it's there because the scenario file format may change in the future and you may want to generate it, or you may just use it to regenerate your scenario file to stick to the change of the target pages or the target API. And the third type of file is the body files. Basically, for each request that returns the body, you will have a body file. It can be HTML, images, pure raw data, anything. So we have recorded the scenario. What does it look like? So let's get to the directory where we recorded our scenario. And let's see that what we have here. We see that we have four files. The first file is the JSON file containing the scenario itself. We see that the Process1 request starts with the 301, which is a redirect to the actual web page, and we see that it's a 200 request on the /en/English pages. So when we play the scenario, it will replay both sequence, and deliver first the 301 and then the 200. So we will replay the scenario exactly as is. And then we have a second request in that scenario, which is a Flux.io web page, and it was served directly. No redirect that time, just a 200 request. And then we have a few more files. We have the URL file containing the list of all the requests that we use to generate that scenario file, so we can recreate it if needed. And we have the HTML file, which are the body that we did download from the web, and that we will use to replay the scenario. So that's it. As you see, it is very simple, and you can understand it and even modify it yourself if you really need to. The next step is to use the recorded scenario file in one of our tests. In the following example, I assume that I would like to test a library that downloads the web page, count the number of times a given word appears on this page, and return the resulting count. You cannot really test that on a real web page because it would be slow, it would be fragile. If the page changes, the result may change as well, and it will prevent you from working offline. So with our recorded scenario file and our test mock library, it will be very easy to write such a test. So first, let's review what the library code looks like. The library is designed to let the user configure the HTTP client it would like to use. And this is always a good practice to let the users of your library customize the HTTP client, because you can thus let the end user decide what is the timeout that is suitable for the type of application the developer is writing, or you can customize the TLS behavior. So this is always a good idea to have a configurable HTTP client in your library that leverage HTTP calls. So here is the code of our library. So we have the page counter struct, which is holding the data the user for library can customize. So we can only, in that case, customize the HTTP client. The new page counter is returning the page counter with default HTTP client setup. So you can overload it if you need to, but you're not forced to pass an HTTP client. And then you have the core method, the count method, that is the core of the library, and that you pass it a URL, a word. It will get the URL from the web, parse, get the body, and count the number of times a given word happened in that web page, and return that value. The next step is to show you an example application using that HTTP library. So here is the code of our client application using that library. So we just get a new page counter and we call on it counts method on the process one page, and we try to count the number of times process one appears on that page. So let's try to use it. So you can go build demo man.go, and we can run it, and we see that we get the count 23. It was 22 a few days before, but now it's 23. Now we have everything to write our test code. The test code just have to set up the HTTPMock library and load the scenario, set up the library to use our client provided by the HTTPMock, and run the test and check the result. So now that we have a test recorded, we can see what it looks like to use that scenario in a test file, in a test code. So the test code is very simple. We have a single test, which is test process one. The first step is to set up our HTTP mock library. We just create a new mock, passing the directory containing our test, and then we load the test one scenario. So we're done for the setup of the HTTP mock library. Then we can set up the library under test. So we create a new page counter, which we do that as we would do in our normal code, but the only difference is that we then override the client with the client passed by the mock library, the client set up by the mock library. So we will be using that to leverage our scenario. And then we call our test code like we would do normally. We call the count method on the process one website, counting the word process one. And finally, like in a normal test, we check that the number of the count we receive is 23 like we expect. And when we run that test, we see that it's passing, it's working perfectly fine. And if I switch off the Wi-Fi and run the test again, we see that we're still passing. So the goal is reached, and we have a very simple test, HTTP test, that is able to run offline and produce reproducible tests. So that's it. As you have seen, adding new HTTP tests in your code can be done in a matter of minutes thanks to HTTPMock library. I hope you learn a few things in that video. I hope you enjoy it and will give HTTPMock library a try. See you soon in a new video of CodeCraft.